Okay, we're looking at the notes for Honors Algebra 2 and Regular Algebra 2 in this case. Notes section 1.1 and key features of functions. So we're going to first of all figure out what a function is, that vocabulary word. So a function, we'll abbreviate it FCN if we want to give a shorter version of it. It's a relationship or a relation between an input and an output value where each input value, so you're given a number, generates only one output value. The input value is usually labeled X and the output value is either labeled Y or sometimes it's labeled with a more complicated version f of x. So you're used to seeing this. You'd do maybe a t-chart where you were given x values of 3, 4, and 5, and you're doubling it, 6, 8, and 10. So that would be y equals 2 times x, but you only get one answer each time, and that makes it a function. Examples of functions include ones that are intuitively functions. And I'll give you an example here. If the input is a specific person's name and the output is the age that is associated with that name, so for instance Jake, and then how old is Jake, that relationship is a function since you wouldn't expect the person to give you two different ages. Current age is what I'm talking about here. So if you asked my age and I told you two different numbers or three different numbers, you'd say, crazy teacher, because you're expecting only one answer per person. When you turn this around and you give a birthday and you're looking for the output to be somebody who has that birthday, that's not a function. Since you could have a birthday, I'll just give an example. February 8th, and you might have several people with that birthday. So you have one input, February 8th, with John, Rhonda, and Mark. And you can do this with any day of the year where you pick a day of the year and there might be several people who share that birthday. One input with several outputs, this is not a function. Okay, let me give you an example here from algebra. We have a graph here with 5 points plotted, and the graph at the right is just a collection of points. It's not a function. So can you circle a pair of points where the x value, same x value, has different y values? So one x value has more than one output. And you can see the point 1, negative 2, and 1, 4, that x equals 1 yields two different y values. Up here it yields y equals 4, and the output down here is the y equals negative 2, so that's not a function. A function can have at most one y value for each of the input x values. Now you'll notice that these points, since they're the same distance to the right but different distances up, lie on this vertical line that we can draw right through them. And this leads us into what's called the vertical line test. And the vertical line test essentially says that if any vertical line, such as the one we drew, passes through more than one point, here it hit two of them, it is not a function if that's the case. So we're going to apply the vertical line test to deciding whether these graphs represent functions. The first one is this oval. More precisely, it's an ellipse. And if you draw a vertical line through it almost anywhere, there's only two exceptions, at the very end and at the very start, you're going to hit this thing twice. And it fails the vertical line test You can abbreviate that V for vertical, L for line, and T for test. It fails the vertical line test, so it's not a function. When you compare that with this upside down V shape here, that only hits once, so it's still okay. That only hits once, so it's still okay. Each time you draw these vertical lines, you're only going to hit once, so this is indeed a function. Yes, this is a function. All vertical lines hit at most one time, and so this is a function. Okay, that ends page 1. I'll pick up these videos on page 2 in a minute.